The university is big, we are so many here. We don't even get to see each other.
Yeah, I mean, I think I have been here a couple of times already. I was here last year to talk about mathematics.
Yes,
this year as well, I've been here.
No, I'm not even talking about the studio, but I'm talking about,
this is true.
Lecturers, colleague lecturers meeting. This is the first time we're meeting, and it's fascinating anyway. But that's easy for you. Yeah. Okay, so listeners, you can join the conversation. Mathematics meets industry. We're going to have a conversation. You can join us via text or SMS 0275 14 49 49, 0275 14 49 49. Also, you can join us live on Facebook, Facebook Live, ATL FM 100.5 megahertz. We're streaming live there. You can join the conversation and also send us your comments or questions. If you have some questions for Doc, he's here and ready to answer them. So, mathematics meets industry.
Yes.
Now, let's start from the basics. What is mathematics?
Yeah, so mathematics is first a science, okay, and it's really an abstraction, or it's a concept of how we do things, put things together. So very basically, in terms of additions, subtractions, multiplication, these are the concepts around mathematics, but that is just the very basic of them.
Okay.
So mathematics is really first it is a science. That is why whenever we talk of the STEM, we say science, technology, engineering, and mathematics. So it can tell you the focus that mathematics is on its own a very bigger problem. Bigger course. Even in the sciences itself.
Okay, so from basic school, from KG, primary 1, 2, 3, up to the junior high school, senior high school, and even at the university level, you hear people talk about the fact that I'm afraid of mathematics. It's a difficult subject. I'm afraid of why do you think people make those comments? Why are people afraid of mathematics?
Yeah, I think firstly is also first and foremost is that you develop interest in subjects when you meet people who have the same interest. That's one, and then based on who you are talking to, it also generates an interest. So if you go to school and you have like a maths teacher who comes and is aggressive, very difficult, he's not relating the subject to the student, then it creates this angst. It creates a kind of a fear with students already, and this is the beginning of the problems that we've been having with mathematics. And also mathematics is a patience science, so you really need, if you want people to jump into it, you need to be patient. You need to use the things that are very easy for the person to break that barrier of difficulty with the person. So you need to first quiz the person gradually and bring the person to a certain state in the subject.
I love mathematics from my basic school through junior high school to senior high school.
Yeah.
And in senior high school, Form 1, I'm saying this to corroborate what you just said. I had a maths teacher who was very good, and I was scoring 90, 92, 95% mathematics because it was very basic. Now, in second year, I met another teacher who made the subject look very difficult. And my performance started coming down, 45, 50%, etc. Now in Form 3, I meet another maths teacher who loves the subject and brought up my interest again. And I remember I had A in core maths. So the teacher factor is very, very important. I agree with what you're saying, because if you have teachers who understand the subject, who have the mastery of the subject and know the right pedagogies to use, they are able to
bring the interest of the person out. This is very true. So it's one of the main things that most people who develop interest in certain subject areas, they met teachers who really kind of made them interested in those subjects. But of course, there are some parents who see the need for the students or the awards to be able to perform in every subject, independent of whether the teacher is good or not. And this is different dynamics, but most students or most people will always give you a story of their teachers and how they were beating them in school, or how they were friendly to them in school, or how they made a subject very practical and very easy for them to access, and it develops their interest from there.
So teachers are very critical,
Yes,
even
this
in
is very
implementation.
implementation. Yes, exactly.
The teacher is the final implementer.
Exactly.
If you take the teacher out, there's a problem.
Exactly.
Okay, so let's now look at this. So is mathematics only about the addition, the subtraction, the change of subject, the equations, etc.? Do we apply mathematics apart from teaching? Do you apply it in other aspects
it's
of life?
really something that is around us every day. And whenever I teach subjects, or I'm teaching any topic at all, first I go from the practical aspects of the topic, because then it enables the students to see, oh, actually we never thought of this. And a typical example is whenever I recently I was just talking to some computer science students, and I was telling them about Owari, the normal Owari games we play at home. And I explained to them that this is a modulo 4 game. It means this is a mod 4. So of course most students know, okay, we know modulo, what we do with modulo, but if you tell someone that Owari is a modulo 4, then immediately it clicks. It makes sense. All the things you will be speaking about, modulo congruences, and these are the kind of practicalities that we can relate to the things that the students are learning, because it's around them. They see it every day, but probably has never connected it anyway with mathematics. So we need to look at the things in our society, the things that are around us all the time, and then see how we can relate the things to the mathematics that we are teaching the students or in the classroom. This is really critical.
So from the kitchen to the car, through to your workplace, to the market, etc., we see some mathematics.
Oh yeah, I mean, I give another basic example. As if you want to go from, let me say, from where we are seated now, if you want to go to Kotakraba market, and I ask students, which road will you use? Most students will just say, okay, I'll go from university, I'll go through Pedu, and I'll go to Kotakraba. But then I have to tell them that, why do you go through Pedu? You can go through the St. Augustine's Junction, and then go through Bacano, and then you're still heading to Kotakraba. Or you can decide to go to the Fansipim Junction and head to Kotakraba, or go through the Agri Junction and head to Kotakraba. Why Pedu, and why are you restricting yourself? But then it begins to make the students think that, oh, actually we have just restricted our thoughts to a certain way. But then you start telling them about what are constraints. Okay, so you want to go somewhere, you are trying to optimize your distance, but you have to think about your constraints. Am I money constrained? Am I time constrained? And is an optimization problem immediately, because then the student begins to see, okay, so actually I'm doing an optimization problem. I'm trying to go somewhere and I've not thought of my constraint. And so I ask them, if money is not your constraint, which direction will you use? And then immediately they start giving you different suggestions. I'll go through St. Augustine's route because I love to see the beach. And so you realize that these are the kind of things that then it brings the issue of, this is an optimization problem, and you are solving it with some constraint. If you don't have money and you have to go to to Kotakraba, you use the shortest path. You don't care if there's traffic, or you just don't care if the flag gate is closed or not, and all the place is congested. You still will use that path because you are thinking of your fuel cost. But if, for instance, you want to go and you are not constrained by money, and you think, I want to get there as quick as possible because I have an appointment, immediately you look for the shortest, how to get there very fast, avoid traffic, avoid all things. And if it doesn't matter if it is the longest route, you want to take. You just want to make sure that you are getting there. And then a very good place to do this is Google Maps.
Okay.
If you put it in Google Maps, it immediately shows you the traffic congestions, how much delay you have,
the number of minutes,
the number of minutes you are going to spend on one route compared to the other, and these are optimization techniques or things we teach them in first year already in calculus, how to apply differentiations. And this is a typical example.
Wow, I didn't know I was doing mathematics when I did that, but I stay around the Agri Memorial Holy Child area.
Okay.
And so I always use the highway to campus and then back. Then one day I said, let me calculate, let me look at the mileage.
Yeah.
And pick because I feel the highway is straight. So, but then one day I picked the mileage from
your
on
place,
the highway
exactly.
to campus, and then from the campus through the beach road and go home. Then I realized that through the beach road to home is shorter. And I was like, okay. So one day I said, let me go through. Then I said, no, I'm in a hurry. I have a lecture. The highway moves quicker. In around Kotokraba, you have traffic. So let me now. Although I know it's the shortest, but let me now use the highway because I'm in a hurry. And you term that as optimization.
Yeah, exactly.
Oh wow! So I'm a mathematician.
Yeah,
that's interesting.
Yeah, so this is exactly what we do, and these are the kind of things. So I even in the classroom when I'm teaching very basic up to applications of differentiation, one of the things I tell them is a very good example would be why we have fans. If you go to our lecture rooms, we have so many fans, and still you see the students, some of them are sweating in certain areas. So we need to think about where we are positioning the fans. It shouldn't just be because the room is square, we should just put the fans anywhere. You need to think critically about how to improve ventilation within a place and position your fans in a way that there is enough circulation. So it might not necessarily have to be row by row. It can be some diagonal direction, but we need to think critically about this. And this is really possible to actually work it out. It's really possible to work all these things out. So these are the kind of applications that sometimes I even joke with them that if you take fufu, we don't know how much liquid or soup should go for a certain amount of fufu. The best way is we need to start measuring the fufu. So say, then we can tell, okay, if you give me 1 kilo of fufu, you need to add maybe 1 liter of soup. To make sure that the person is well equilibrated. So
but
these are the kind of things
our mothers at home, our mothers who didn't go to school, who are the chop bars, are able to measure the amount of soup.
This is from data, so that also comes into play. Based on experience and based on how many years the person has been doing the fufu practice, is able to tell that this soup, 2 ladders is enough for this amount of fufu. So these are all mathematical things that come into play in our daily lives. I mean, and certain things that are, for instance, a typical example on our campuses that I feel we should start putting into practice. Very critical things in mathematics. You can decide on location, bus allocation. We call them scheduling problems. So if you want to put buses at certain places, you can think about it. Where do I put buses such that students benefit in their movements around the society? Or where do I put certain shuttle areas that students will benefit, then they don't become congested in certain areas. So these are all scheduling problems that we can think about. If you want to design a timetable, for instance, it's really called a scheduling problem that we sometimes, whenever I'm having a problem and I go to the lecture rooms, that it's too small for the class, or they are not getting a good lecture place, it gets so frustrating. And these are things that we can pose as problems to mathematicians, because these are problems that have been solved. And sometimes I play games around they don't realize it, but they are games that they are mathematical meanings. An example is if I ask people, how close are you to the vice chancellor? You can think about it. You can say, okay, do you have a direct access to the vice chancellor? You say, okay, no, but I know someone who knows the vice chancellor. And this is called graph theory. So you can immediately draw your graph to the vice chancellor. Or if I ask you, how close are you to the president, you can tell me, oh, I know someone who knows the president. So it means between you and the president, you are two people interval, you know. So someone can just take you to the president because of this connection. And these are the things that if we understand very critically and understand them well, we know we can address a lot of problems in our society. Because if you have in a society where maybe within every one person, everybody knows another one. So if you know the president because of one or two people, then immediately creates a problem of corruption and creates a problem of certain problems that you can almost solve, because everything is networked and everybody knows everybody. And then it creates these problems. So these are the things that implementations of these things.
All right. So a very good morning to you, Professor Howard. Dr. Moore talks about lecture theatres and allocation, and he's a chairperson for the timetable committee, university timetable. So, Professor Howard, good morning. Good morning to you, Saram, and also to you, Josephine Jehuapia, all of the exams unit, University of Cape Coast. We need to apply mathematics in these things, as Dr. Moore puts across. Doc, I teach educational statistics.
Oh, okay.
And one of the measures in there, it's in that's measures of central tendency. And I was given an illustration in class about a farmer who planted two types of tomato plants, and then the amount of fruits he is able to plug from each of them within the week, from Monday to Sunday. And you have the scores, the number of fruits there and all that. And after calculating for the mode, the median, the mean and all that, we were able to answer certain questions, especially that if you are a farmer, which of these plants would you want to cultivate or even advise? And we're able to pick them. And so I told them, this is how we apply mathematics or statistics in our daily life. So from what you're saying, then there are mothers in the market, the farmers, the engineers, the nurse at the hospital, everybody across board needs some mathematics.
You cannot be a nurse without knowing basic additions, because some of the medications, for instance, you need to take maybe 200 milliliters and then apply to a certain liquid and apply to a certain substance and then mix them up and inject a patient. Or maybe sometimes your medication, you are supposed to give the patient 250 milligrams 2 times in a day. If you meet a very, very poor nurse, they may give
in terms of mathematics.
They may give you 500 milliliters. And then these are things that causes patients death. So these are really critical things that we cannot make little of them. So in every industry or every setting, and God, honestly, there is a new book published last week by one senior colleague of mine in the Netherlands, and he writes about how mathematics has been able to be has been applied in a lot of European settings, and why they have certain solutions that are robust. And there's another new one actually that came out also last 2 weeks, which is the German industry's use of mathematics and how it has helped scale a lot of things. And usually I read these kind of things because these are the things that are in our settings we need to look at, and we need to look at a lot of the problems around us and ask ourselves, can we pose them? In Europe, there is something called the European industrial mathematics, where every year, every 6 months, certain companies they meet together, and then they invite mathematics professors, mathematics PhD holders and stuff. They come and they call it industrial mathematics meetings. So the industry comes, they pose the problems, and then the professors are split into different groups in different areas, and then they work with the industries directly. So if you come from your company, you bring your problems from your company, you come and pose it to them. They spend about a week or two just solving the problem and making sure that they go through the solution really critically, discussing it one-on-one with the company. This is what we've done. This is what we have. This is what it means. And then the company will say, okay, if we choose this solution, then this is what happens to our company. This is what. So these are the things that you need to discuss critically. And I think that if companies decide to go this way in Ghana, there will be a huge jump in the industry or in the settings that we have at the moment.
So Dr. Moore says mathematics is life. Anyway, let's just remember that the issue segment is proudly brought to us by Salgin Medical Center. They offer services such as comprehensive eye care service, eye surgery, laser procedure, dispensing of spectacles, ear, nose, and throat treatment, corporate eye and ETN services, even in Saturday services. Remember, they are located at opposite Wesley Girls Senior High School, Cape Coast. You can call them 0332 091 232 or 0575855379 or email asargent@gmail.com for further inquiries. And also brought to us proudly by the Cowbell range of products: Cowbell fortified choco milk drink, Cowbell strawberry, Cowbell coconut, Cowbell coffee, Cowbell choco malt, and more. Great minds think alike. Cowbell energy for winners. Cowbell milk. It's about 38 minutes past 08, and in about 2-3 minutes we'll be ending the conversation, although it's getting very interesting. So Doc, let me find out from you, do people who study mathematics, like BSc mathematics, get jobs aside teaching?
Yeah, I mean, there are a lot of people. If I recall some of my mates from tech, for instance, there are a lot of people, and sometimes I get surprised about even the jobs some of them are doing. There are some of them who are medical doctors in the US. And so I always say, just 2 weeks ago, I started advising final year students in my class. I said, look, you need to plan yourself. You need to plan yourself and what you want to do even after your degree, and give them a direct path of what you can do. You finish bachelor's, you are 23. Maybe you do 1 year national service. If you want to do medicine, you are still capable. You just have to find yourself back in the university. It takes you 6 years and you can do medicine. But after mathematics, it is really, in Ghanaian society, the jobs are really very limited. So you can find yourself in a bank, you can find yourself in an insurance company. We have a lot of us students in banks and insurance companies. We have some of them in teaching as well, and we have some of them also doing masters, PhDs in US, and who have decided to go into data science or into actuarial science and many other opportunities. So, or even come to the university setting as a professor. Because one of the things that I must also say is Ghana has about 70 PhD holders in mathematics.
I see.
So it is really, really poor number to see that we are 31 million people almost, and then we have just 70 PhD holders in mathematics. It's not enough. So we need to create a pathway for more people who want to come into the university settings to gain that pathway and come in, because we need a lot of them in the system as well. So it is not just the teaching aspect of it. There are several aspects of it, and currently one of the things I keep impressing on my students is to learn programming, and I enforce it on them. Learn Python, learn R, learn MATLAB or Octave, because now the world is such that you do not even have to travel anywhere. You can, if you have the skill, you can sit at home, you can solve problems, and you can get jobs directly in other societies or in other countries.
Right. It's 41 minutes past 8, and fortunately our time is up and we have to wrap up the conversation. So Dr. Moore, in wrapping up, as part of your concluding remarks, how do we increase our interest in mathematics as part of your concluding remarks?
So my conclusion will be that first, we need to, the pedagogy is very critical. The people teaching the basic schools, the high schools, have to explain the mathematics in ways that are very practical or very relevant to the students who are being taught. And then also the second aspect is that we need to see mathematics as a as a tool for solving problems.
Okay.
And if we see it that way, we'll be able to move forward, and we're able to do things really critically. And this goes to a lot of the things, even in our society. I've already said timetable scheduling is a mathematical problem. Bus scheduling is a mathematical problem. Optimization, where to go, which route to use. And these are all mathematical problems. And if we can pose them, and if we can get the right people to work with, these are things that can easily get very robust solutions that are well known for many years already.
Dr. Stephen Moore, Senior Lecturer, Department of Mathematics, UCC. Doc, thank you very much for your time this morning. I've really enjoyed the conversation.
Thank you very much.
And hope to see you soon.
I'm always around.
Okay.
This is one of my project students.
Oh, okay.
Godfred,
Okay.
I supervise his bachelor's project.
That's, I see. And he's using mathematics here to stream live on Facebook.
Yeah, exactly.
So that's one of the applications of mathematics, you know, the timing and all that.
You need to streamline. You need more people liking it, more people sharing, and then you need more people to get it, because then it creates a network of people. And this is a typical example I also always create is that how do you think that Facebook sends you friend suggestion? They just look at your closest friends and your other closest friends, mutual friends that you have with your friends, and then they send you friends of them, and then say this probably might be a friend of yours. And this is what we call the graph theory.
Okay.
This is our network graph. So we use this to find friends. We use this to determine who can be a friend, who can be an enemy, and stuff like that.
Wow. So mathematics is life.
It is the basics of creation. When Jesus said, "Let there be light," he knew E is equal to MC squared, right?
Wow. Okay, Dr. Stephen Moore, thank you very much for your time. I really enjoyed our conversation.
Be informed on the Atlantic Wave. The Atlantic Wave on ATL FM 100.5.